congratulations with very successful presentations yesterday. It was not unnoticed. It will be positively reflected towards your progress towards successful completion of the course. And today we are starting new software. It was not yet covered. By the way, if you take refreshments, you notice on the last group. So good. There are formal academic goals of the course, and maybe there are some expectations of every attendee, including instructor of the course. But in addition to like formal things that, not formal, practical things that will hopefully give you most benefits, will be completion of research projects, and you may start thinking on which area of research you want to complement with computations. There is no requirement about software and method that you will be using to successfully complete your research projects. But there is an idea that everyone should get more opportunities to have broader arsenal of tools for computations and for making projects. So the successful completion of projects will be major criteria for your success, for grading, for everything. Right? If you have in mind some, I wouldn't say exotic, but some specific software that you like, I don't mind. Some of you may be already attached to Gaussian and like to complete some projects. It's fine. Some of you may could be attached to HyperChem or yeah. Well, you will not bypass FASP. I will invest most of the time for FASP. I'm just telling that there are no requirements. You can use anything. You are not mandated to use FASP for your projects. Because I was criticized by colleagues who, like yesterday, there were not too many guests on the presentations, basically none. But typically, those meetings are attended by a larger number of visitors. Maybe because previous years it was on regular time. You have a luxury of having prime time when most of people are watching movies. Right? So there was a criticism from previous years. They were colleagues were approaching me. Are you twisting their arms and making everyone to make projects with VASP? Why no one did any other software? No, it's not mandated. Use any software. So we didn't start the density functional theory yet in class, but we will start. You completed the chapter 2 about quantum, and we will invest about a month on density functional theory. It is available in Gaussian, and those of you, Hannes, he was showing that there is a menu tab where you could select density functional theory method DFT, and then you select so-called functional. Right? It is another subdivision in which specifies the method. Feel free to do it. Then Ben nicely introduced the Gaussian type wave functions, different types of bases, but everything that Ben was introducing was atomic-centered localized base set. Right? Those of you who will not sacrifice tomorrow lecture for starting of the break, you'll hear a little bit about periodicity. And those who sacrifice will hopefully listen to it in recording. So Originally, there was this course is in the chemistry department. Most of who are taking it are this chemical background looking on molecules, which is like a group of nuclei and electrons connected together and surrounded by vacuum, gas, liquid, solid, right? But this year there are some attendees from engineering, physics, and polymers and coatings. Right? So if you look broader on materials, there are a lot of things in the world that surrounds it that can be qualified as molecules, right? So can you give me an example of a substance that is not a molecule?
Well, elements are not molecules.
Okay, neither atoms nor molecules nor gas nor liquid.
So something that's not matter?
No, it is matter, but it is not molecule. And well, of course not atom. Huh? Yeah, you can say electromagnetic radiation. It is matter, but it is not molecule. Yes, formally it is correct.
A block of metal.
Yes, like a piece of metal, you cannot call it molecule, right?
It's a crystal.
Crystal lattice. So it's a lot of materials are made of crystals, or maybe some amorphous materials or polymers, but they're not. A polymer is not a molecule, right? Because it's like.
I thought it was just a combination of atoms and molecules.
Then I as a molecule salute you as a molecule. It's a little too broad.
We just say it's matter, right? Kind of like crystal matter.
Yeah, and formally, Kurt was correct. Like electromagnetic radiation is also matter, but it's not matter of study in this course. It's more like for quantum optics. So what is missing in Gaussian? Can you do crystals in Gaussian?
To an extent.
You try really hard.
You can. It has units. You know who did crystallography? Who tried to do crystallography? And I don't know, via lab or by stealing a key to X-ray diffractometer lab, or just making friendship with X-ray diffractometry expert.
With the database.
No, not database. Who's
Oh.
seen X-ray diffractometer in person?
I think we got a tour along those lines.
Huh?
Intensity versus 2 theta graph.
Density versus what?
XRD, right?
XRD, yes.
Yeah, so we made a graph of intensity versus 2 theta.
Oh yes, intensity versus 2 theta. Yes, correct. Does this recall? Does this sound familiar to anyone? Then there are like series of peaks,
Yep.
right?
Yep.
Have you seen the diffractometer itself?
It's like that thing with the glass case in the front, and it's like.
Okay. You did?
I've seen it.
Mary was announcing a course by Angel Guidov, who is teaching, starting about now.
Yeah, it would be about now.
I think he will not reject to show you diffractometer. He's getting Severy basically to watch these machines and prevent strangers to enter the room. Well, I'm exaggerating. So, what is X-ray diffractometer? Or if you haven't seen the device, there is no reason to ask the question. So through these diagrams, so you put a sample and you get signatures of diffraction at different angles. X-rays are scattered or diffracted from the matter. And depending if the matter is periodic, if it is a crystal, there are different patterns. And by analyzing, this is more for powder X-ray diffraction, but for crystal, it is more dimensions.
Wait, is it like using X-rays in the medical office where they X-ray you and they look at your bones, or is it different?
It is different. in medical office, it's more like regular photography.
All right.
It just rays going through tissues, and where there are bolts, they are reflected. Where there are other tissues, it comes through.
Okay.
And here it is not passing through, but reflecting or diffracting.
Refracting? Okay.
Diffracting. And if there is a regular pattern, the diffraction happens only at specific angles. Like
Okay.
if it goes into sample with one angle, it will pass through another angle, it will reflect, and then it will form interferometry picture that can be measured. Right?
Oh, you mean how it diffracts when light goes through glass or other material?
You're thinking of a refractive index?
No, it's more like for analogy with optics. Maybe if you take broken compact disc and look in a point source, and you have rainbows.
Okay.
Things like that. But it's not a perfect analogy. So the idea is that if there is a crystal periodic and you use X-ray diffractometry, these signals can be processed by special mathematical tools, and they reproduce atomic coordinates. Right? Mary was presenting it at lecture number 7, presentation number 1, right? So, what is crystal? What is the difference between crystal and molecule?
Crystal has symmetry. Well, it has
Several symmetries.
Several
Some
symmetries.
molecules also have symmetry, like C3,
Right.
rotated.
A crystal is a periodic arrangement of atoms.
Periodic. Yes. It means it has translational symmetry. So if you shift your arrangement of atoms by a specific distance, a specific vector, all atoms will come to their images, to their counterparts, to
Okay.
their analogs, right? So crystals are infinite. And most of the materials needed for engineering and cool stuff are not molecules but periodic systems. So Gaussian has units to read X-ray crystallographic CIF files, and it has an opportunity to build periodic cells by pseudo atom that it is called TV, which stands for translational vector. You can do it, but it is not. Gaussian was not originally designed for periodic systems, and it is not optimized. So the performance, I'm not criticizing, but it can be better. Okay, so the basis set, different options for basis set introduced by Ben, all were atomic localized. And if you need periodic systems, it's not good. You need a basis that will work for infinite piece of material, right? So which infinite functions do you know? Well, Gaussian is also infinite, but it goes to 0 if you go far away from a molecule. Who told this? Oh, I didn't doubt that you know. Anyone else who wants to be?
Wait, are you asking like which periodic functions can be used to represent periodic structures? Okay, sines, cosines, and exponentials, like any linear combination.
Not any exponential is imaginary.
Oh, right.
Yeah, good. Everyone agrees on that? Right? Who give me like a little secret comment if you need me to expand this a little more. So if you have wave function localized in a point of an atom, it's not as good for periodic system. If you have like a little piece where there's atom 1, atom 2, and then in the next box it will be again atom 1, atom 2, right? So we need such functions that will protrude through all images of the atoms. And Kevin suggested to use sine or cosine or e to the power I kx, right? Who knows how to plot ikx? E to the power ikx. Okay, lift hands if you do not know how to plot this function.
You mean like plotted on the imaginary axis?
Okay, you know how to do it. Who needs comment on how to plot this function? 1, 2, okay, substitute. Ben and Gage should be well familiar with this, right? So, who is author of this expression?
Euler.
Yes. So it's best friend of Gage and Ben, right? So imaginary exponential is consists of two parts, real and imaginary, right? And if you want to plot it, you need to make a 3-dimensional plot. So there is a x-axis, there is real part, there is imaginary part, and then the real part changes as cosine. I'm not yet done. Imaginary part changes as sine. Right? But at each value of x, it is only 1 point. 1 point in the plane with projections on imaginary and real. So it will start making a spiral. Okay? So if you look of projection of a spiral on one plane, it will be cosine. On another, it will be sine. And it is 3-dimensional function. If you need to extract real imaginary part, it is always possible. It's not a big problem. But people love this function because it's the easiest possible way to perform integration, right? If you integrate exponential, you get exponential. If you differentiate exponential, you get exponential. So it's so much easier to perform operations with exponential rather than sine and cosine. Okay? Because for sine, once you integrate, you get sine, another get cosine. Back change sine for the minus to plus. It's possible, but too many efforts. And with exponential, it is easier. So we are going to use a software that will replace, like in Gaussian, you saw this, how to say, zoom, this big set of, large set of many basis, set of basis sets. So when introduced yesterday, it was like 40 or several dozens. In the software that we will focus on right now, there is only one basis set. It is plane waves, exponentials, and no matter which calculations you do, basis functions are the same. Okay? So we'll probably get to details of theory later in class because we do not want to waste time, and I want to give you right. Exactly. So there are, let me probably sketch a plan what we it's so much easier to operate this machine when you're presenting. I was having fun focusing it on the speakers yesterday.
several things. So where to log in, and of course do open directories. We will do it on those who do have access to CCast and have license permission to invest can link back and through us. All others, be attentive. So, as time goes by, during the next couple of days, I will arrange, you will see emails from the National Energy Resource Supercomputer. They will tell, like, do you want to have an account? And you should answer yes, and then sign some forms electronically. Today, and there is a way to access it through Photon. So first you need to log into Photon, and then there will be a command to access. I think that space tilde point SSH slash NERSC space, and then continue next line, but it is the same one. CORI period NERSC period GOV. So be careful you are interacting with the development. Without my instructions, do not do much things. Just see if you can get there. Next thing is to get to the right directory. So as you have, those of you who got experience in using CCast, you may have noticed that on many public computers, the user home directory is limited in space. You cannot put there more than 200 movies if you want to misuse it for your personal reasons, right? But there are additional directories for large-scale computations. Okay, so after you get there, the path to a directory which has sufficient amount of space is too long, so I'm lazy to type it. But if you do more space where, you'll see some prompt, and then you do CD space and to the right place. So attract my attention. I will make a circle and chat to everyone, show how to do it.
Does this have a password?
Huh? Okay, coming back.
Oh, and the smell of that.
So let me make a circle and check that you are there, and then I'll give more instructions.
But these are on top of the SSH. Why is it asking for?
Oh no. You haven't. You do not have access to. First, you need to log into.
Okay.
Photo, right?
All right.
Huh?
What?
No.
Everybody's doing the same thing.
If you work only from here. So just. Make an appointment for yourself. Most of the time, no.
Hey Mary, what's that C thing? CD thing?
Mhm.
Tools to write CD, space mover, space square.
So you're right here, right?
Yeah.
Is this from the director of Gary? Like right when you said more?
Just
Okay. This looks like all small templates.
create directory for yourself. Yes.
Yeah, so.
Oh, hold on a second, I think that's a.
I think I figured out what we're doing.
You already done?
That just gives you the path, right? And then you
Yes.
CD
yes.
into
You
that.
know that, for
One sec.
war. So we don't need to for the whole class.
Well, there it is. You just go right in. Just here's your path. Just the path. Because I don't know. Because it's not a directory. It would show like,
Directory for yourself.
Okay.
yeah, that's all I got. Sorry.
Okay. Yeah. Thanks, Mary.
Yes. You may record it yourself in the future. More or
Yeah, also, I emailed you yesterday, so.
Yes. Yes, I will,
Yeah, anytime you have to.
no, yes, I know.
Read. Be, they have the same setup.
We will use it short. No. You don't need to go to one page. Everyone logged in? Give me a sign if you didn't. You are there, okay. So please do some activity to prevent logging off, but be respectful to other users. So it's nationwide. There is, if you type who, you will see like 400 users logged in. So for short time you can type TOP, but do not overuse it. Better maybe do VI test file or something that doesn't take resources. I need to deliver a message and then we will do exercise together. So, what is the, which file does one need to run job on Gaussian? You were presenting it yesterday. Input file, right? Everyone agrees, right? What's the end, or what's the extension of the input file?
.com or .in.
Okay. I apologize for making a question which is more appropriate to the kindergarten level, but be careful. How many input files you need for Gaussian? One. Okay. So now you will see why many people hate WASP and do not want to switch from Gaussian to WASP. So there are four. I've forgotten how to count. There are 4 input files, and without having 4 input files, there is no chance to start any calculations. So the software is really powerful and useful, but it is who was given analogs with rockets and cars yesterday? Cars. So if Gaussian is like automatic change of gears,
then VASP is more like manual stick shift, right? So it is a little less user friendly, but the outcome is a little more powerful. So I don't know how it is related to car, but POS stands for position. So you know, in Gaussian you store everything together, right? And we missed one of the part of the versatile use of Gaussian that later on one may bring in if you really need to be. There is another section for ECP, effective core potential, to do heavy metals like lanthanides, actinides, or very last row. So in-car is more like line after hashtag where you tell what Gage and Mary were telling, and Nathan too. So like when you start Gaussian, you tell like, give me single point energy, or give me optimization, or compute normal modes for me, or make a transition state search, or whatever. So assignments what to do are stored in the in-car. But as you see, it will be much more than one line. Because it is like stick shift, you need to tune your input carefully and with many parameters. We will use templates. You will not redesign it any time, but it's longer. Now, this I'll tell about it later. So pod car is pod is potential, right? So the calculation of all electrons for each atom is very expensive, and it is needed only if you do X-ray, not X-ray diffraction, but X-ray spectroscopy, if you want to excite core electrons higher up. If you do not care about X-ray experiments, if you need only UV spectroscopy or chemical reactions, you need only orbitals near like HOMO and LUMO, within axis of visible and ultraviolet radiation. So for these purposes, one can replace core electrons, like for heavy elements, you can forget about 1s1, 2s2. One can replace them just by homogeneous charge. Same as we were doing experiment in our class. We were ionizing and then assuming that we are putting all electrons back to the molecule, ionized molecule. So the first electrons that we will throw back in, they will not form molecular orbitals. They will form very localized s orbitals around each nuclei, and they are so boring. So there is no reason to deal with them. For next element, for elements with many electrons, there are a little trace of background charge exerted by core electrons onto outer electrons that are participating in chemical bonds. And the degree how these core electrons affect valence electrons are stored in this file. So we will, I hope very much that it will be time to do it today. So basically, if you have hydrocarbons, only carbon and hydrogen, then this pod car will contain two records. One record for hydrogen, another carbon. If you have, like if David will decide to do cesium, lead, iodide, perovskite, then pod car needs to have three records: for cesium, lead, and iodide. As many elements, not as many atoms, as many elements, repeating elements. And key points, I fear to speak about it. It's very brief file, but it has some special concepts. In brief, what is the net velocity of electrons in the molecule? Like if you have, if I carry, mid and I are two big molecules. I don't know about others.
Like if I'm standing here and I have so many electrons, what is the average velocity of all my electrons?
Like a vector sum?
Yeah. Huh?
Is it temperature dependent?
Average. Do electrons contained inside me move anywhere right now, in average? So 0, right? Because I'm a molecule, I'm not a periodic solid. If it is a periodic solid, there are like ground state structure, wave function. There are molecular orbitals which do have non-zero velocity. Because the solid is periodic, there are solutions, there are molecular orbitals that move like a train continuously. One molecule moves, one orbital moves one direction, another direction, and it needs to be taken into account when dealing with solids. Periodic boundary conditions, and K, you know, some people use letter P for momentum, and some people use letter K in a sense like if you multiply by Planck constant, then K is a wave vector. If you multiply by Planck constant, it will be momentum. If you don't, it will be wave vector. But it is the same sense as momentum. Okay, so let me suggest we will do the simplest molecule. Well, VASP, the software, can do molecules as well. And as a first attempt, we will do the same thing we started in Gaussian. We will do titanium hydroxide, right? So if I'm speaking too slow, if you're bored, glance through this PDF file that I shared, and you can be ahead of the class. But I will slowly do things, and you may or may not follow. But the homework will find you anyway. Sorry for black humor. So, what I did, maybe it did work. No, it didn't. So, do not do anything. I will just show a line that I did, and that you may need to do in the future. But now we will skip, and I will just provide it. So, from my experience in our previous labs here, I do have the .log output of the Gaussian calculations, right? Who was teaching us how to use Babel? So, Queenie, the assignment was to teach everyone how to use Babel in the command line. So if someone doesn't know how to use it, ask Queenie, he will teach you.
Okay.
So if we do have output of Gaussian and we apply Babel, input Gaussian 09, output XYZ, and then you call file whatever you like. Right? It will parse. You know how the log file looks, and you know that one can parse right information, right? It will parse energy. Sorry, withdraw like last word. Parse coordinates, optimized coordinates. And then if I look on this file, so first is number of atoms, then senseless comments, and then name XYZ, name of element XYZ, right? 3 coordinates. So I did it, and you will be able to do it later. Just do not waste time right now. And then I'm doing SCP of this file to right place on the National Energy Supercomputer. Okay, so. Copy. So if you so now please try to do ls 2 periods Oscar XYZ.
We
And
have to be,
you need to be in your directory that you have already created.
so, what
Ju-
if,
Huh?
what if we're on this thing that you helped us with?
Yes.
How are we accessing our stuff?
Later, I will cover it. Right now, you need only one file.
And I'm saying.
I know your question. I understand your question.
Okay.
It's possible and not very complicated. We just don't want to waste time right now.
Okay.
Wait, so we had type ls //
Yes. Do it and see what you see. Let me know what you see.
And now it will copy. Copy all this file into the directory. Okay, try it.
If I can't see it either, that's the problem. Oh.
I'll make a search for that.
No problem. Good.
No. He just copied it. Because hence the dot. Yes, it means directory list.
He's like going into deep and
It's just listing all the files that it just checks.
Oh.
So, we're just kind of looking to do this case.
I didn't get to you, sorry. Oh, okay. Got it, okay.
Okay, so now, please, there is a thing that I cannot take responsibility and help any minute. Please make sure that you are not logged off for inactivity. Either do TOP or open some file or just each 5 seconds hit space. So, the Gaussian format is very forgiving, user-friendly, and I would say liberal. So you can list atoms in any order you want. VASP software was written by Germans, or more specifically people from Austria, who like to be a little more organized. So they do not allow liberal approach. So atoms should be organized in order. If you have carbons, you need to list all carbons one after one. If you have hydrogens, you need to list all hydrogens one after one. Right? So you need to arrange atoms. So what I'm doing, I'm renaming this file that I should have. I'm doing the same as you did.
Can you move the screen so, because that little screen is
Oh yes,
blocking
yes,
that
yes.
screen.
Thank you.
Okay.
For sure. Better?
Yes, yes.
So copy postcard here, and if I'm looking on it, I see that it is not in the German ordered style. So I'm rename it. Move.
My web search turned something up for us and it is not in the German or their style. Have a look.
Can you mute yourself, please?
It's not in the German or the style.
Oscar, some other name
Okay.
you like or do not like. XYZ. So I just renamed it, and now remove Oscar. Okay. Now there is a command sort, which sort. See, it arranges everything. Sort, and then it arranges first number, then all hydrogen, then all oxygen, then titanium, right? And I do not want to put it on the screen. I want to forward. I learned that the symbol bigger can be verbalized as caret from you guys yesterday.
Mm-hmm.
Okay, sort, caret, postcard. That's crazy. And then I'm doing VI postcard, and I do remember that between number of atoms and elements there should be space. So I type I for insert, hit enter, then going down, and type DD, or escape, semicolon, I'll repeat, DD. No? Okay. Where it is? Escape, DD. Okay, done. Escape, colon, right click. I will repeat, do not worry. Oscar XYZ. So now it is in the right format. Number of atoms, all hydrogens, all oxygens, or all titaniums. Germans will approve it for calculations. Now, some of you may feel discomfort with VI editor, right? Which is natural. I also was feeling discomfort for first 15 years of using it. So let me just make a second copy and do things slower. Sort, caret, postcard 1. Now, VI, postcard 1, XYZ. You do not put 1, you do postcard. So after typing VI, it brings you to this editing mode. So this shows which file you are editing. This shows your X and Y coordinates where you are in this matrix of symbols, right? 1, 1. If you go between lines, it changes, it tells like line and column. Now, I'm going this marker to the top edge here.
Okay.
Wait, so VI name file opens up the text editor with your file and allows you to make text edits to it? Okay.
When we were on Photon, we also used which editor?
Nano.
Nano. I didn't check if Nano is installed on NERSC. Maybe. It is a little more user-friendly. But VI, by definition, is installed on any Linux machine.
Okay.
And if you need just to add one space, one empty line, it's not a big deal.
It's all keyboard shortcuts.
Yes,
So
correct.
that's how you do it.
Yes,
Right.
keyboard shortcuts.
Yeah.
So, Give me a sign if you are not in this window.
We're not in this window.
They're not.
Okay, I'll make it so.
So I
Yeah, I got.
Enter. And then for exiting, escape.
Oh.
Right click.
That's my molecule.
we saved and quit from the editor. So close
Space and region.
I insert
We're on a roll.
Well, the first 15 years is complicated than integration. Delete for sure. And if you need to delete like 1,000 lines, you do deep, 1,000 deep. Then delete
1,000 Ds.
or 1,000 Ds, yes.
Or you could just do X.
X for one symbol and D for complete line.
Yeah.
Weird.
You did? You did?
No, I got it.
Insert. Escape.
Oh, okay, so we just got rid of the line then.
Yeah. So.
Oh. Well, so you just got rid of the information line? after- oh,
Yes.
okay. Tilde.
0, 0, 0. Enter.
Oh.
Plus minus of 3. So next
Okay.
step. There, as time goes by, there appear a lot of people try to develop a shell, a mouse-operated user-friendly shell for creating VASP style files in GUI editors, but they're not yet reliable, although they will be next year or in 5 years. So I'm offering some homemade procedure that will just speed up the procedure things. So generally, you have seen in Gaussian or maybe in Avogadro or in other editors that you may need to rotate your molecules, sometimes shift, especially if you need to put together two things, right? Like donor, acceptor, different angles, or docking, binding with different sites. So this has a little reflection of it. What if you need to rotate? Rotation has 3 arguments. Rotations around x, y, and z. But what this thing does, here, it was here only Ben and Mary. This little code, you can see it in this binary .f. It's like very short code, maybe 20 lines. It was written together. We are sitting or side by side by your current advisor and your previous advisor. But main thing, what it does, it creates. Well, you hit enter. It reads file name postcard.xyz, and then it asks you for 3 numbers. Rotation around x, rotation around y, rotation around z. If you don't care about rotation, you just put 0, enter, 0, enter, 0, enter 3 times. And then it creates additional files. Okay? So please try 0, enter, 0, enter, 0, enter. And it is, it looks a little crazy, but it is a quickest step to create healthy VASP input files. Lift hands if you have problems running this little thing. Okay.
If you want to save, just keep trying it. It works.
Okay.
On the third try. Yeah, the 0, 0.
Error.
Zero.
Type 0.
It's empty. Strange, right?
Oh,
okay.
In rotate XYZ, but
so this file, this code reads.
I see there's a tink in there.
Yes.
Is that related to
Yes.
the
Yes.
tinker?
Yes. Is it here? Okay. Those, like, if some of you are Fortran programmers, you may see that it just looks for file named postcard.xyz. If it is input file is named with different name, it will not read it. So it should be not postcard1, it should be postcard. Okay? I'll make a circle and make sure that everyone good. Good? So it should be space. What? Ask each other. I repeated it 11 times, and someone should have memorized it. So you did it. You got it?
I think so.
P32,
No.
I agree with that.
Not a text file. You're lucky. Huh? You disagree? Oh, you don't need to do more. Did you? What I did?
You just wanted us to do it, right?
No, only if you are super curious
Oh.
and have nothing to do. Okay, you got this.
Yeah.
Let's check this again. Okay, it is there.
Okay.
Now, there will be prepare your internal strengths. It will be not hardest thing in your life and not hardest thing in the course, but it will not. It will need attention. The next step. So take some coffee. And I will take coffee.
H20? I'm just kidding.
And feel free to use cream. Set it. Whew. Edit please this jar of coffee near the poster that tells coffee and computers epic fail. You see it?
Oh, well, that's a shame. That's why we have lids for things.
So,
We're supposed to be typing this, right?
oh, sure. What? I'm doing something wrong. Not anymore.
Okay, there we go.
Okay, so if you, it doesn't hurt to type it again. So if we are using WASP to describe molecules or zero-dimensional quantum dots, then just literally repeating this command is sufficient for your happiness and success in this world. But if you will, and you will, as a homework assignment, if you if you will use WASP for true periodic structures, then these three numbers at the end mean really a lot. So, slowly but surely, this is a Perl script. It converts from Tinker to WASP, and latest update was made by Walter Duncan in 2015. His name just left here. Not 15, 05. So here is your rotated postcard that was created at your previous step by Fortran code. And here after space, it is a name of the file that you do need. One of the four files for to successfully run WASP. File with positions of atoms. So, what are these three numbers? Maybe I can save my intellectual effort and ask if anyone can guess.
Coordinates.
They are XYZ, but not quite coordinates. Any other?
Oh, dimensions.
Huh?
Dimensions.
Closer, but not quite.
Ox.
Offset?
I'm super happy. So offset of what from what? Like offset myself from the chair.
How far you are from the origin?
Not bad. Not bad. You're competing. So, interview bandwidth he needs. That's interview. So offset of what to what?
Oh, periodicity.
In which sense?
How things come in and go out and where they land.
No, imaginary will be here. Here, no imaginary.
Okay.
So I'll try it several times, but it is one of the. It's not the hardest thing in the world, but it is the hardest thing to communicate in short time. So please forgive me if you do not understand it. It's my guilt. Let's put it this way. Suppose, well, this model will be of 9 atoms, but suppose we have molecule of 2 atoms, which is not hard to imagine, like H2. If you practice this command with these numbers equal 0, 0, and 0, it will create a box literally around these 2 atoms, minimal box that will contain them, right? And if you create such minimal box with 2 atoms, it means that in the next periodic cell, the atoms will be close to each other on non-realistic distances. They will be like smashed into each other and they will interact, repel each other heavily. So if we want to create a healthy periodic system, we need to add a little offset of vacuum around. Okay? And next periodic cell should have this 2 atoms, but they should have vacuum around so that the atoms do not collide into each other, do not interfere. There should be space. And this 3 parameters, AX, AY, AZ, it is a distance between these minimal boxes.
And this is our boundary conditions.
Well, it is offset between, I don't know how to explain it. It is a necessary parameters to represent boundary conditions, and explaining by single word, Ben was correct, offset, right?
So it's the space between each molecule in a crystal, basically.
Yes, but the word molecule will not apply to a crystal.
I mean atom.
Not each atom. Unit cell may consist of more than 1 atom. It is offset between minimal boxes.
Okay, so the offset between each unit cell is
It's not absolutely correct, but it is a right train of thought.
Is this huge distance between each other kind of that help to minimize the energy?
So, if you are speaking about tightly packed crystals like metals, this offset should be set approximately equal to bond length, right? Which is not much. So for carbons it is like 1.4. For gold it will be like almost 3 angstrom, so range, right? But there are nanostructures which can be 0-dimensional, 1-dimensional, 2-dimensional, right? Which means that along 1 dimension you need to set periodic boundary conditions. Along another you can put vacuum. So what does it mean, vacuum? It means you can artificially, like, if I do not want this to be a truly periodic solid, if I want just a gas of like diatomic molecules, right? Then I can make this box really big, right? And put amount of vacuum between these boxes substantially large, right? So far that the molecules do not feel each other, so they do not attract or repel each other. If you are really picky and you want to publish in top journal with 7 significant figures, you may add like 20 angstrom and it will be true vacuum. But it is very expensive because basis set of plane waves charges us not for number of atoms. You can use like 1,000 atoms calculations, but it will be possible. But what is expensive in VASP is vacuum. So if you use 20 on each side, it will be almost impossible to compute. And as a good approximation, like 8 angstrom of vacuum is good enough.
Guys, hit top. Make sure. Make sure you hit top while we're waiting.
Yeah, otherwise you need to log in again. So try to practice this command, and upon, by the way, Kevin and everyone else, if you put here 0, 0, 0, it will tell the size of this black minimalistic box, right? So our titanium hydroxide molecule is approximately squeezed in the 4x4x4 angstrom box. And if you add this 888, then it is about 12x12x12. Okay. So I will make a circle checking that you are there. And if everything went correct, here is the healthy example. I hope healthy. it should work. Example of the postcard file. There are some other surprises that will need my comment, but if you please create this file and bring it to your screen. Good. Okay. So, what is your impression about how this file looks like?
I see some type of matrix.
Is it beautiful?
Yeah.
Just the positions of the atoms, right?
Mm-hmm.
And the T,
Well-
is that stand for tense? Is that tensor? Is it T's?
Oh, let's discuss and make guesses. What does letter T stands for?
The values are different for
Huh?
values are different.
Yes. We will discuss it. So, Mary is curious what is T. Anas is curious why these numbers differ from Cartesian coordinates. What are other questions to this file?
Why does it say selective dynamics and what's direct?
I don't care.
Okay.
But the numbers are really important.
Okay. What about the 441? Is that important?
How many titanium ions is in the model?
1,
How many oxygens are in the
okay,
model?
Okay.
4,
How many hydrogens?
4.
So,
That's
first 4 records will correspond to hydrogen. You see, it's a German organized way. So, 4 hydrogens, then 4 oxygens, and then titanium. So titanium is approximately in the middle, like 0.5, 0.4 something, 0.4 something, and the rest is around. So T stands probably for translate,
okay.
or yeah. An opposite will be F for, I don't know, forbid or freeze. Remember when Mary was presenting scan of direction coordinate, she was selecting pair of atoms to update bond and keep all others atoms unchanged. Or if Anas is a big guru of hyperchem, right? Okay, raising star of hyperchem. You know that you can select part of a molecule that will become green and the rest will be unselected. And then you do optimization or dynamics and green part, selected part will move and the rest will be frozen. Same in the VASP, you can it means you select atoms, you allow them to translate, and F you can freeze. Okay? So if you have big substrate that you do not want to optimize, you can freeze it, and a little thing that you absorb or dock, you can let it move. So, question of Anas, why the numbers are different? Let me ask you, do you see any number smaller than 0?
No.
Do you see any numbers bigger than 1? And you remember that positions of ions were like at least 4 angstrom away from each other. How to interpret it? I know that Nathan is expected to know it, so anyone except Nathan, please answer.
Does this have to do with the graph you showed us? Or no? Okay, right.
Is it like percentage of
Yes.
long X,
Perfect,
Y, and Z
perfect.
in the unit cell?
Do you understand, everyone?
No.
Then ask Ben. He's responsible to communicate this idea, because it is correct.
If we imagine that the molecule is in a unit cell that has X, Y, and Z, each number is the percentage along X, Y, and Z that the atom is.
So here, this 12, 12, 12 are the sizes of the box, of the simulation cell, right? If coordinate of a given atom would be 0, it means we x projection. It will be that we are at the leftmost side. If it will be 1, it will be on the rightmost side.
Okay.
And point 1 in between. So it is fractional coordinates.
So just multiply, just say like, for example, 0.54 by 12 to get the coordinate?
Exactly, yes. Make sense? This is done with intentions for to make it universal. So the code will work anyway, whether you use small or big system. And it will be unified way to track errors. Good. Okay, so out of 4 files, we have 1. So we are 25% ready. The rest will be a little easier. Do not worry. I think we will be done in the remaining time. So, for the in-car, I suggest we use templates, and I hope no one erased it yet. In-car dash GM period in-car. So just copy from the template, and later on we will discuss. There are several pre-made versions of the in-car for almost any circumstance in the life. But let's take the one GM for geometry optimization. So CP space tilde slash bin slash in-car dash GM space period slash in-car. So you're moving your in-car file to your working directory. And we are going to watch it and slightly modify. Or maybe no, it's good enough. So, by the way, I'm not sure that I will be able to do it in class or the lab, but everyone is encouraged to browse the internet for forums or websites describing VASP. You can find some wonders that I'm not aware of, and then teach all of us here. So, this is content of in-car file. Give me a sign if you were not able to copy.
Well, the first copy that you put down?
Yeah.
It gave me an error? The
Just,
second?
no, CP space tilde slash bin slash in-car dash gem space period slash in-car.
Yeah, that one worked. I was just saying the one above didn't.
It did work or it didn't?
The one you just talked did work. I'm just saying the one above did not. But
Oh, okay. Then I'll make a circle, and you can keep enjoying this one and guessing what is what. Yes, you are correct.
you see what I'm saying?
Yeah.
you got it, right? And you know all this stuff.
Yeah, I got it.
Okay. So remember, first it was presented by Anas for Gaussian. The simplest job in Gaussian is energy, single point. So NSW means the single point and energy optimization in some sense are the same job in Gaussian. But if you tell geometry optimization with zero number of steps, it automatically means single point. Means do not change geometry and just run electronic structure once. So NSW equals 0, it means single point. Precision low. This is important parameter. This is, remember when we were in chapter 1, we were pretending that all of us are little computers that optimize geometry, and we had a parameter, delta t, that somehow relates to Newton equation of motion. It shows how dense grids are that we use to explore our. So it is analog of this parameter, which is measured in femtoseconds. So in some sense, this parameter means like if you would optimize geometry, how far we could, or if you run molecular dynamics, how far we can go within a time interval of 0.8 femtoseconds. L wave equal true is important if we need later on to do molecular orbitals. And the rest we can cover later. We just need template. Same thing for the K points. K points, space, period. More K points. So right now this template is specifically done for sorry for terminology, so-called gamma point, when we consider a system as good at the same level as we would do in Gaussian. So no translating permanent motions, just molecule without momentum.
By Monk forced?
Those who traveled to Sunnyvale conference. Ben, did you last year?
No.
So only Mary in this class? He always comes to this conference, and when I was postdoc in Florida, he was sitting next door. So it's a gentleman who designed how to reduce amount of grid points in momentum space.
Oh.
But right now we do not change it. We use it as a template. And we are 75% ready because we have postcar, in-car, and K points, right? We need just pod-car, and if any of you are versatile professionals in Gaussian, it will be somehow analogous to ECP, effective core potential. Take another coffee. It will be less counterintuitive than previous steps, but it will need concentration. So the potentials for each element are stored in different files, and there is a very long path to get them. So we will need to get this like building blocks and put them together in the right order. Make sense? Who was presenting CATS yesterday? Oh, okay. So CAT stands for concatenate, right? So merge several files into one. So for the podcar file, and by the way, in this PDF, you'll see many things that we were doing together. If the recordings will not work, or if you forget, you see here like this rotate XYZ thing to WASP. I just find it quicker to communicate in person, but there is a little description. So module show WASP. So it does show pathways to different units of this software. And the one that, well, here are executables, but we will run it through job scheduler. It's just in case. Here are pseudo potentials that we will pull right now to create podcast file. And later on, we will need this VTST scripts. This is the collection of community built scripts to process input and output from WASP. Similar as for Gaussian, there are like CubeGen and FormCheck, and there is like several dozen of useful codes for WASP stored in this directory, VTST scripts. So now we need to copy this pseudo potentials. So what I'm inviting you to do first, copy this line and do ls of these things. You'll see abbreviations. LDA, PBA, PW91. So have you seen the abbreviation LDA in the drop-down menus for Gaussian? Or maybe SLDA? I suspect that Anas may have seen it. Oh, Mary recognizes PBE.
Yeah.
Who else recognizes anything of these abbreviations? Ben? Have you seen any of these abbreviations before?
Yes.
What are they?
Local density approximation.
I don't know what you're doing here. You are past. Okay. So anything else?
PBE, I don't remember what it stands for, but
It's for its last names, first letters of last names of designers, but one of the. Okay, we will discuss what they are for next 3 weeks in class. So let's ls of the PBE. So the names are Perdue, Burg, Erzenhof, and it is if you are doing DFT, density functional theory, with Gaussian, right? Then you need to select which functional you are using, right? And we will go very careful and detailed with definitions of and math background for these things. But there are different sub-levels of DFT, different ways how total energy is computed, and there are many options. And PBE is one of the who did it yesterday? NS did everything. It is he showed a balance between cost and precision, right? Between like from semi-empirical to MP2, right? And if you are stick with DFT, different functionals have different cost and precision. So PBE is like balance in the middle, optimal balance between cost and precision. Huh? Well, it's not the most precise, but it is not most expensive, and it is a good starting point. So, and then there are PodPow PV, pseudo potential PV. And now, if you hit enter, what are you going to see? Either try it or guess. What I will see if I hit enter at this point?
More information. Lots of stuff.
So if you do not, Sudipto is correct. Ask him.
I have already pressed enter.
So explain what I mean. Basically, you will see periodic table, right? List of all elements that we know. You got it? Everyone got it? Except me. And for many elements, there are different ways how they are represented. But basically, it is a tree of subdirectory, with pseudopotentials for almost any element in the periodic table with more than one option. Okay? So what we do need right now, we need to do head of the postcard, just because I do not count on my memory. And I see that I need only 3 elements: hydrogen, oxygen, and titanium. And it is critically important to keep the order. So first I need hydrogen, second I need oxygen, third titanium. WASP doesn't respect names of the elements. It respects only the order. So whatever I take first will be considered as hydrogen, or will be considered as potentials for this first element. So hydrogen, what car, bigger, or caret, what car. So according to, who told it to me yesterday? Nathan or Kurt? That the symbol bigger can be pronounced as caret. Okay, everyone agrees. So, cat, yes?
Yeah, I can need your help with your.
Okay, I'll present a couple of lines and then make a circle. So concatenate, then this long path, and you do not need to type it, of course, right? You copy paste it from module show WASP. And then first you select hydrogen. Nothing complicated, just careful. H, hydrogen, slash podcar, then bigger, which means append to the new file named podcar. Hit enter. Then instead of H, I put here what is my next element, oxygen, O, and hit enter. Then I put here titanium and hit enter. So by now, this file podcar will include 3 blocks, 3 subsets for each of the elements. And if I want to make a little sanity check whether I'm at the right page, I can do grep pbe podcar. And if file is healthy, it shows me that there is a PBE for hydrogen, there is a PBE for oxygen, there is a PBE for titanium. Right? And I want to be consistent and use the same functional for each element. Although technically I can use different functionals. Okay, I'm going to make a circle and check if you all are on the same page.
Okay, so.
LS was only for information. No, we do not see but cat. Cat is for concatenate. Taken information. We need first we need hydrogen. First we use two potentials.
So we're adding hydrogen and oxygen to the overall car file?
Yes.
Okay.
And now titanium. Okay, you're done. I'm just checking because sometimes, as a human, I sometimes forget. Checking with the records for each of them. Record for hydrogen, record for oxygen, record for titanium.
Got it.
Good. Yeah, good question. So Sudipta asked what will be if I use different order. So good molecule is when we have titanium, oxygen, hydrogen, hydrogen. If I do swap first two, hydrogen and oxygen, it will WASP will not complain but it will make calculations for the following molecule: titanium, hydrogen, oxygen, titanium, hydrogen, oxygen, titanium, hydrogen, oxygen. Okay? It's something a little strange chemical. So you just need to be careful in order of elements. Make sense?
Yeah.
Man, you done? This part? Okay.
Something I want
Control C. Sure.
Well, you really done it once.
So LS was looking for the information. There is no hard file to concatenate.
Did you make it? So for titanium, and then we'll do
Next
for TN.
oxygen. Next dating. Good. Okay.
You took that correctly. G or EP. There's a space, right?
Yes, there was a space. So, that, no, we should start.
Actually, I think it's
Hydrogen? Oxygen? Check. Okay, very good. Okay, we are 100% ready for things, right? Well, we need only one thing to run, right? Give me a couple of seconds. I will provide a template.
So everything we've done now up to this point was to prepare those 4 files you mentioned?
Yes.
Okay.
Yes, and now we need to launch them.
All right.
Okay. Okay. What if I do not remember? Then I'm going to okay, I recognize one of the files that I just created. So I'm copying the from our class subdirectory query dash debug period. I can also copy regular as well. Dash. So before running more. So the scripts for submitting jobs are a little shorter and more user-friendly than those on CCast. So there are limitations. The debug queue will start running within like 15 minutes, but from each user account you cannot submit more than 5 and run more than 2 at once. But since we are trying a really small model, we can put wall time. Well, it will whoever starts first will complete quicker. So probably everyone will be complete within the remaining time. Number of nodes and total number of CPUs. Again, this is a little ambitious for this little molecule. I can safely edit it and put maybe number of nodes 1 and number of cores like 10 or whatever, 16. I do not need much. Still, it will be like using space rocket to deliver grocery from the store. And if you want to differ, I can put name here, titanium hydroxide. So as batch to submit, right? And please modify if you have energy to do it, because unlike the CCast, amount of hours per user is limited. It's like one needs to write grant proposal, and there is enough hours for anything we need to do, but do not waste it without need. So right now, after job is, and I will make circle, make sure that you are doing it. After the job is submitted, you can monitor it by SQ minus U username, and or you can do grep and then give this number of job. Or you can just give the name. So you see, it is there are some jobs that are running, and there are some that are in the queue. So I suggest you all try to submit, and I will explain. And if
why are the nodes all different? Oh, the nodes selected, I get it.
there are like 20,000 nodes.
Yeah, I
over
was
there.
like, okay.
One more person has submitted, and he or she didn't modify the number of nodes. It was by definition 8. The one I submitted and renamed as titanium hydroxide is 1, and second person made it 8. Okay, third person submitted it with changing, instead of OH, naming it HO, and made 1. It will change to like priority after a couple of cycles. I'll make a circle and check how things are going.
Okay, I'll ask you at Corey regular.
So you may just save resources without spending the money.
I don't see man right now.
Oh, man, because I think
That's all
Your phone did that.
Did you know that have the survivor?
Now you choose one or
No. Survivor? No. Certification. Yeah. I don't know what they're doing. Or the
whether to close it or not, and then after some time you give the number.
They pick you for.
So as soon as we have about, okay, this one is that Kevin just submitted, right? Test in organic, and it has no status yet, but it will update it. The previous one, TIHO, it's already in priority. So do not worry much. This is a really quick queue, but a little waiting is because if you exit it and type who, I do not want to look on the list. I just do WC, which is not water closet, it's just word count. Okay, it's pretty humble. There is just 116 users currently logged in, which is not much. But amount of, it serves the whole nation. And different parts of this cluster at different years took spots in top 20 supercomputers. Later on, if you do some big calculations, you may update and make it more efficient. But right now, there is just no reason to request too many resources. You also want so this is the name of this job. Yes. So this one is yeah.
I just didn't know which one was it.
So it's a little ambitious to use 200 CPUs for 9 days.
What?
And also PC share. Let me know if you have other projects. This week, How are you doing? By the way, if you use not 10 core, but 1 core, maybe you will indicate. It is because we submitted so many developers jobs.
Except that's not on here. That was this is not CCAS. This is very different. CCAS -F job. Or just doing that a whole bunch of jobs. Or I think trying to close that or dash
Not within the cluster. Sometimes all the time. Does anyone has a job completed? Okay, good.
Slurm?
Uh-huh. So you have job completed?
I can check.
As soon as it gets to the queue and starts, it will complete it immediately. So this.
It's, I mean, this. No, honestly, it's not done. Yeah, I forgot to.
Because it hasn't gone out. Because you can get it. In order for it to actually change,
That weekend, the 15th.
because you would get something.
15th to the 7th.
At least down here.
I'll be back in Scotland.
That's gonna be horrendous.
This is the temperature just on the city.
Doing it just
Because that's more utilities. Every place you go to, probably suggest the building that okay. So Joe, for you here. Okay. So the. Joe, well, tell Joe things to do. Oh, there's like 50,000. Yeah, there's cities.
In theory, the comments are the exact same. Yes, because they're both just ways to submit the comments.
Thank you.
So the one who named the job one inorganic with, oh, it is CG, it means already done in like 49 seconds. Who was using one inorg as the name of the, okay, so yours already done. So we have three pending. You'll see them done very soon, but maybe do you have the one that I submitted done? Okay, the one I started as the at the beginning is already completed. So as your jobs are done, look inside, follow me. If you, since we are over the time, you may just go into my directory and copy files. But first, watch what I'm doing, okay? So if you look for the list of files, so here the ls-ot arranges file according to the time when they were created. So last files before submitting jobs were this postcar, in-car, kpoints, podcar, and then this query debug, right? Then I did submitted the job to the queue. And then it did appear, again, let me ask a question. How many output files does Gaussian generate? No. Oh, two, three, like couple. right? Check file, log file, what else?
Right?
Error.
Maybe error, yes. So 2, 3 files. Here, 1, 2, 3, 4, 5, about a dozen, right? You know, you see why some people hate VASP and stick with Gaussian. So the analog of .log file, the most important file for initial assessment, is outcar, out like output. But other files are also important. Another file that we are not going to use right now, but maybe on the next meeting, is wavecar. In some sense, it is very similar to check file. It does contain molecular orbitals. And of course, we will plot them, right? There will be ways to extract molecular orbitals out of this file. But now we are going to look on the out card. So Control C, more out card. So in some sense, it has technical information same as Gaussian log file. At the end, if it is normal termination, it doesn't write jokes like Gaussian does. If you looked into Gaussian output, you saw jokes, and I never saw them repeating. Maybe because I'm not running it very often. Maybe after some period of time they will repeat. So it tells how many time used, seconds. You see, it's very humble use of the resources. But if you get this report on used time, it means job is completed. Now, if you scroll up, you will see a thing that Kevin was asking questions to Queenie. Yes? So how do you interpret this columns? You see? You recognize it?
Mm-hmm.
So it has orbitals, the absolute number of orbital, energy of orbital electron volts, and number of electrons that sit on this orbital.
What are you opening again?
I'm looking on the last 200 lines of the outcar file. If you do not want to scroll through the whole outcar, you can do, later on we will have scripts, but tail minus n200 outcar, something like this. So I know that Queenie likes ionization energies and electron affinity, right? Which are homo-LUMO energies. So they're here, -7, -3 for the same model. If you look, well, in Gaussian you can also get better results by using DFT rather than Hartree-Fock. But you see, if you know properties of titanium hydroxide and titanium dioxide, the gap is a little above 3 electron volts. And here we get more into right range. When we used Hartree-Fock, the gap was about 13 electron volts, and here it is about like 3.5, right? So it's not ideal. There are many errors in this method, but for initial assessment of properties of materials, it is a really good start. And there will be ways to, like, this is energy that you need to apply to oxidize it, and this is the energy you gain when you reduce it. Okay. So let me walk around and check that each of you can find this table.
When Varston terminate, should we just look at?
Huh?
Should we just look at yours, copy your table?
By the time I will make a circle, probably yours will terminate normally. Good. Your job is finished? Good. I don't know, maybe geometry is different, or
Okay, so you're saying maybe like more outdoor or something?
put in the capacitor and also count.
7 and 8.
Maybe you could use different geometry, or maybe. Oh, okay. So you didn't add, you put 0, 0, 0 instead of 8, 8, 8. So there is nothing bad, but can you share experience with everyone? What you observed?
Okay.
Like story of success and failure. What did you observe in your rhyme?
I said that K value or what is it?
This adjustment or offset.
Yeah, offset. So I said that 0, 0, 0, not 8, 8, 8, and but I got that the band gap energy is positive, not the negative one.
So I can bring your data on the screen because it just will show what's the penalty of not using this offset. So right, it is your data.
Yeah.
So the values of HOMO and LUMA energies are positive, and the gap offset is like 0.9 electron volt instead of 3, because because they interact through the periodic boundary conditions. So I think if you redo it with enough vacuum, it will come to normal. Yeah, thank you for reporting. Ben? Good. Good. Things are good. How are you? Oh, you have completed.
Yeah, mine is complete. There's two.
You're luckier than they are.
No, there's two completed.
Oh. Yes.
Outlaw.
Yes. You guys all are lucky.
Yeah.
Where?
So should
Lucky,
I?
lucky three.
So should I type more outcome?
Yeah.
Like, okay.
I just tried the last 3 words and now
And then just hit space several times until you see the right thing.
But then I can skip all of that by using the 200.
Good.
No.
Oh. Something you
Yeah, that's not just the interface. I mean, that you want to do, yeah. Yeah.
Just wait.
Don't do it. Don't do it. We're using the network.
I didn't see one.
Conversion requires full pseudo potential generation.
But you
Mine is 39567. This is 39557.
That would be, if it doesn't, yeah, it is.
Mine is 17.2. This is
I thought it was.
just enjoy it.
no, this is
You done?
this
So this is what I got for the file.
What's it?
Is that right?
No.
It's going.
We'll figure it out later. Just enjoy looking on.
Population 4. But it's kind of pretty big.
Okay, perfect.
Okay. So, I will think overnight how to entertain you through the break with some homework.
Yay.
But I think it's already late enough.
Yes.
Enough, right? So when you are doing this, please do not forget to type exit at the end. Make your own records how to log in back if you need it, but type exit to complete session. If we do violate too many rules, the government agency will come after us.
What do you type
Huh? To exit. Exit.
Action.
So next time we miss, or I probably send instructions how to download files, right? But as a minimum, we will do much more than minimum. But as a minimum, we need to transfer files, make density of states, and plot orbitals, right? Things that you know how to do in Gaussian. And then later on, we will have other sections of computing spectra, absorption spectra, running molecular dynamics, and exploring anions, cations, and excited states for reactions. So it's a program for at least 2 or 3 meetings. So in about 3 weeks there will be another session of presentations as we typically do. Okay, I will stay here to answer any questions, but I think it's enough for today. Looking forward to see either all of you or some of you tomorrow in class.
We'll be there.
Okay.